Toyota has recently taken one of the boldest steps in the history of the automotive industry, adopting an entirely new approach that goes completely against the prevailing vision for the future of mobility. While most companies are racing towards a fully electric future, Toyota has decided to revive internal combustion engines. According to its CEO, the brand new engine Toyota is working on will disrupt the automotive world and change the game entirely. But this decision didn't come out of nowhere. Toyota's insistence on preserving combustion engines has always been a cornerstone of its strategy. These engines, known for their legendary reliability, were one of the main reasons Toyota has maintained its market position for decades. So, it makes perfect sense that the company continues to develop and modernize them to stay ahead of the competition. This time, however, Toyota has gone above and beyond. We are witnessing a revolution that surpasses even the hybrid revolution Toyota once led with the Prius. That shows just how important this new technology could be. So the big question everyone is asking now is, what is this new technology? The answer is Toyota's brand new hydrogen combustion technology. We're not talking about hydrogen fuel cell electric vehicles like the Toyota Mirai. This is something entirely different. Toyota is currently developing internal combustion engines that run on hydrogen instead of gasoline. Fuel cell vehicles like the Mirai suffer from several issues: poor performance, excess weight, and limited practicality. Even after more than a decade since their introduction, they're still not as usable as needed. However, the environmental benefit of hydrogen is undeniable. It is the most abundant element in the universe and is unmatched in terms of eco-friendliness. That's why Toyota remains determined to develop technologies powered by it. This direction is gaining more relevance now, as serious questions are being raised about how environmentally friendly lithium batteries truly are, especially considering how lithium extraction pollutes soil and water. Despite ongoing improvements, charging time and driving range for electric vehicles still need major enhancement. And that's where Toyota's brilliant solution comes in. Combining the power of traditional combustion engines with the environmental benefits of hydrogen could eliminate the flaws of both systems. Interestingly, BMW had already tested this idea in the late 90s and early 2000s and got promising results. But those experiments never made it past the prototype phase due to the lack of infrastructure. Today, thanks to Toyota and the Mirai project, things are different. Hydrogen infrastructure is better than ever, making a real launch possible. Toyota is now developing hydrogen combustion engines with many similarities to traditional engines, most notably the internal combustion principle itself. Gasoline engines, in fact, serve as an excellent foundation for hydrogen conversion. Currently, Toyota has 2 hydrogen engines in its portfolio, each designed for a specific purpose. The first is a 1.6-liter 3-cylinder turbocharged engine, the same one used in the GR Yaris and GR Corolla. Even with the fuel change, the hydrogen engine sounds almost identical to a gasoline one. 2. The second is a 5.0-liter V8, taken from the Lexus RCF and targeted at larger vehicles like the Toyota Tundra, Land Cruiser, and Sequoia. Surprisingly, both engines retained much of their power after being converted to hydrogen. Although there's a slight drop in performance, it's barely noticeable. However, to maintain Toyota's well-known performance and reliability, significant modifications were required. The most notable change was to the fuel system. Hydrogen is a gas that must be compressed and cooled into liquid form. This requires new fuel pumps, modified injectors, and high-pressure resistant fuel tanks similar to those in the Mirai. The ignition system was also adjusted to use special spark plugs tailored to hydrogen's properties, and the ECU, electronic control unit, was reprogrammed to optimize performance and efficiency. The most significant upgrades were in materials and structural design. Traditional components were replaced with more durable ones to withstand hydrogen's intense reactivity. This included valves, gaskets, camshafts, and the crankshaft. Thanks to all these changes, both engines performed impressively during tests in models like the GR Corolla and GR Yaris. The V8 is expected to be used in large off-road vehicles later on. But with great power comes great responsibility. The new technology still faces a major challenge: how to source hydrogen. Despite its abundance in nature, hydrogen doesn't exist freely. It's locked within chemical compounds and must be extracted through complex processes, most notably electrolysis. Electrolysis is expensive and difficult to implement everywhere. That's why running a hydrogen car today costs more than 14 times what it takes to run an electric vehicle. A massive disadvantage. Even if we manage to extract hydrogen easily, storing it remains a major hurdle. Hydrogen is highly reactive, requiring armored tanks that increase the car's weight, reduce performance and range, and take up significant space. And although the hydrogen refueling infrastructure has improved, it's still limited. That makes daily use of hydrogen-powered cars difficult. Even worse, hydrogen can ignite spontaneously if it leaks, posing a serious safety risk. Despite all this, Toyota is confident it can overcome these challenges. The company is betting that hydrogen will spread far beyond automobiles into shipping, agriculture, and industry. As global adoption rises, costs are expected to drop significantly, possibly making hydrogen even cheaper than gasoline, though perhaps not cheaper than electricity. Toyota is also working to reduce fuel consumption in its hydrogen engines, aiming to keep operating costs low. The tanks, as long as they're maintained properly, are considered safe. Also, hydrogen combustion engines are far cheaper to produce than electric cars, making them ideal for mass production. But here's the real surprise. Toyota is now developing an entirely new method to store and use hydrogen: ammonia engines. Instead of separating hydrogen from chemical compounds, Toyota proposes using ammonia, which consists of hydrogen and nitrogen, as a direct fuel. Ammonia is flammable, making it practical and safe to store compared to hydrogen. It's also abundant, cheap, and more economically viable than gasoline. Toyota has partnered with China's GAC to develop the world's first ammonia-powered engine, a 2.0-liter, four-cylinder engine that runs on liquid ammonia. Tests show it's 10 times more environmentally friendly than gasoline. While it doesn't produce zero emissions, it's still better than electric vehicles, which involve highly polluting battery manufacturing. Technically, ammonia engines are very similar to hydrogen engines, allowing parallel development of both technologies. So we reach the big question: is hydrogen truly the fuel of the future? There's no definitive answer yet. But one thing is clear: hydrogen has massive potential. Despite its challenges, it remains the only current option for emission-free internal combustion vehicles. And with better infrastructure and falling costs, hydrogen may become one of the cheapest energy sources. As criticism grows around electric vehicles due to high prices and battery pollution, hydrogen looks more promising than ever. Even massive projects like Saudi Arabia's The Line are betting on hydrogen as a main energy source. And with technologies like ammonia engines, hydrogen will spread, directly or through alternative forms. Over the next decade or two, hydrogen could become one of the key forces driving humanity toward a more sustainable future. In the end, Toyota isn't following the trend, it's creating a new one. While the world fixates on electric cars, Toyota is redefining the future of combustion engines through hydrogen, opening the door to a new era of sustainability and innovation. Will hydrogen be the dark horse in the energy race? Could we soon see powerful, affordable, and safe cars without a single drop of gasoline? Only time will tell. But one thing is certain: Toyota has already taken the lead.